now that we have, we know how to enter the data, let's say that we have, let's pick a study. You remember last time I was in Zoom, I was kind of talking about the statistical methods. So a meta-analytical model. Let's say we have 10 studies like this, and we want to use a meta-analysis to investigate what is the common effect across all of those studies. So I'm going to open an existing data set. Actually, the one exactly the same data set that we use that I was presenting last time. I was in Wengen, and I think I was. Let's pick this. Where is it? Let's pick comparative studies. Okay, let's pick comparative studies. Something like this. Okay. Maybe I have the data. Let's see if I have the data. No. So I'm opening the PDF from last time, and now this is a practical session. So how do you enter this data? Let's say this is a PDF, publication. Imagine this is a meta-analysis, because there is some people even not extracting data from original publication. There are people extracting data from the meta-analysis in itself, because meta-analysis, okay, this is the state of the art up to today. So in 6 months, you may want to expand the meta-analysis. So this is very common that, let's say, you just build on a previous meta-analysis available. So you don't do the work from the beginning. There is a meta-analysis published a year ago. Now there has been a few more studies, and I want to see if there is any change.
And that's a legitimate thing to do.
Exactly. You just
the job for you already.
you take advantage of someone else's work. And the funny thing is that people are so jealous. Sometimes we talk about the data, how precious they are. But this is published data. Of course, we have spent some time picking up those 2x2 table, but come on, it's nothing compared to the principal investigator work. So, but even if you ask, please, can you give me this data set with 10 lines of data? The meta-analyst most likely won't tell you, no, you won't get anything, because this is work.
Yeah,
exactly. Go on PubMed and and do the job. But let's say I want to import this. Let's say we have a meta-analysis published, and I want to get all of these data sets. This is a PDF. Okay. So how do we enter the data? Let's say you're going to do this, but I just want to. How do we enter this sample of data? Using the approach that I suggested. Well, I would do this. Copy and paste is always work. You just select this. Okay, you select, copy, and then you paste it. You see, like this. Clear. Input is a string variable of I don't know, 20. And this is, of course, any string has to be included into double quotes. Okay, that's what I'm doing. I'm just see how much it takes to copy and paste. This. So this, okay, this is a string of variable. This is the study type. Study. Imagine the name or whatever it is. Then we have cases exposed. Then what else? We have the cases exposed. Then the totals. The totals exposed. The cases unexposed. The total unexposed. Then we have an estimated risk difference. What is it? This. A risk difference. The lower bound and the upper bound. And done. How much does it take? Nothing. Nothing. You clear input, and now you have your data set good to go for the meta-analysis. So the study, cases, totals, and so on with a measure of effect. So imagine, opening an Excel file, watching, it's a waste of time. And if there is something wrong, it's easy because I have the syntax. If something is wrong, you can recognize and fix it. If you work with the Excel file, everything is so much more time consuming. So programming, it makes sense if you save time. So those are machines that can help you to save time. If you're wasting more time, it doesn't help. There is a room for improvement. And so here, this is the 10 studies that I have in mind. And here you can see the risk difference and the low and the upper band. Let's say that, the previous meta-analysis use the risk difference as a measure of effect. Okay. But you're building on that. Okay, I need the same 10 studies. Maybe you want to add a few more recently published, but you don't want to conduct statistical inference on the risk difference. I want the relative risk ratio or an odds ratio. So you want to not only build on top of the previous meta-analysis, you want also to change the target measure of effect. Rather than thinking on the absolute term, you want a relative measure. So you don't need the risk difference. You don't need these columns, right? So how do you, you can remove it from here. You can remove it like this. Okay. You don't need that. So you can do this. Yes. Yes, I will share this. So we all made all these comments. Now I'm trying to go with the flow of question because I think is better than sending around code with no explanation. So, but at the end of the day, or at least I'm going to share this conversation that we're having on this. So you get a do file, something. Of course, you're very welcome to type in because that's the way you learn it, but you do it yourself.
I would like to copy and paste what you have.
Exactly. I can paste it.
If you can copy paste the Word file and you upload it on the Dropbox, you can copy paste it.
Yes, or I can paste it in the chat, in the Zoom chat. I think so. I mean, let's try. I think that typically you have to. Let's try this. Okay. Chat. I'm still on. Chat. Here it is. So you copy that and you paste it into the do file. It should work. If it doesn't work,
we publish it tomorrow.
Good. So, as you can see, this is a quick way, copy and paste from the PDF directly into the do file editor. Just add a couple of lines at the top and at the bottom, and we are good to expand or analyze the same data in a different way. So rather than presenting risk differences and confidence interval, we're going to conduct statistical inference on the risk ratio scale. It doesn't work? Out of the room.
It would be nice to have the file of the lecture.
I'm right.
Yeah, it's right.
The lecture from last
the PDF.
And with the meta-analysis paper. Yeah.
Okay.
So that we can,
I see. Maybe I have a Dropbox. I can put it, let's see, Dropbox. I'm gonna do it. I'm gonna fix it. Look at this. So if this doesn't work, I'm gonna grab the PDF from last time and I drag it on Dropbox. You see? There it is. Now you have it. And so let's do this type of work. So as you can see, risk differences, well, if you don't need risk differences, you can drop it. Drop risk difference low in the upper band. Just get rid of it. Okay? Drop the inference presented in this meta-analysis because we want to conduct the target, it's called the estimate, the target of statistical inference in our meta-analysis is the common risk ratio. Okay. So we have two groups, treated, untreated, exposed, and exposed, binary outcome. So how do we do it? And this is the data. Let's do a meta-analysis. Now, a meta-analysis is super easy. You have different ways of doing it. One is to use, if you have Stata 16 or 17, there's official Stata command for you. And they have been developed over the last few years. There is also a user-written command with a much longer history, Meta-analyses. You simply type Meta, cases exposed, non-cases exposed in this order, and then you decide the measure of effect, and you're done. Let's do it. Let's do it. So, strategy number one. Strategy, old approach. Okay, old approach is using Meta command. And so this is you have to download it from the internet. It's a large archive. Meta command. So this is not official Stata command, but it has a long history, and I think it's nice to keep in mind. The official Stata implemented meta-analysis only recently, just copying what the users already wrote. Let's see who wrote Meta command. It's a long explanation. Let's see. The guys who wrote this command are actually British statisticians. So the guy who wrote this from Bristol University. Oh, there is a command. So it's Meta. But I want to tell you two different ways, the old approach and the new approach, because I realized that we have to complement the official, because the official is more useful.
Some people might not have that state on there. So I think it's good.
Exactly. So Meta is going to work.
I mean, your trial license is for the 17th, so you can use the new way to do it. But
I'm going to show you the old approach that is working since Stata 7. And also show you the new version, so we can see what's the matching between the two approaches. And also that this can be nice because certain things I have to say, when a software is young, it has to be further developed. And the users are always much ahead of the company because the users know, okay, if I have to write a command for meta-analysis, I know what I want and I'm going to write it. So the users, they're always far ahead as the official company. The company is just following the users. But of course, what the company can offer, it may not be enough. So that's why I'm saying, let's go for official and non-official Stata commands and see how they relate. And so you can choose what to click depending on your flavor of Stata. All right, so let's do the traditional one. The traditional one is using the Meta command. If you don't have it, find it and install it. So and the way you use it is to specify, that's the syntax. So we want to do a meta-analysis, two-group comparison of binary outcomes, use the number of events and non-events in the treatment and control groups. So command, cases exposed, C1, no cases exposed, and C1. And then similarly, no event treated, event in the control group, C0 and C0. In this order. So of course the order, it matters. Cases, non-cases. Okay, expose followed by again expose. So do we have this piece of information? If we have it, So we have the cases and the totals. So we need the known cases. So we have to generate a new variable. So we need to generate known cases. So you take the totals minus the cases. And then you generate known cases unexposed. So you take the totals divided by the cases. And now we have everything we need. C1 and C1, C0 and C0. That's the meta-analysis. And then you choose. Do you want to conduct inference on the common risk ratio? So you're going to write risk ratio. And then what kind of estimators you want to use to combine the studies? Well, let's use inverse variance fixed common effect. All right, so 3 lines. Once you enter the data, 3 lines. With 3 lines, we actually 1 line, we get everything. We get the statistical analysis and the forest plot all at once. So here you can see the 10 studies. You can see the risk ratio within each study, the confidence interval.
Did you put a label?
Yes.
At the name of the study?
Yes. Yes. So, so with Meta, you specify the cases, known cases in that order. So you get this table. Let's look at these results. So we have 10 studies, 5,610 participants included. This is a meta-analysis with risk ratios as a measure of effect. We are using a common effect inverse variance model. And so this is a classical, it's called common effect or the traditional fixed effect approach. So the basic assumption is that there is a common treatment effect underlying those 10 studies. And here you can see the study-specific estimates, 0.79, 0.86. We have a study-specific confidence interval, the weight that each study has in the meta-analysis, and the summary, the common effect. The common effect is 0.74 and 95% confidence limit with a statistical test of not treatment effect, plus some measures of heterogeneity, statistical heterogeneity about the common effect. So this is kind of extensive output with a forest plot all at once. If you want to add some options, I think is forest plot alcohols study. For example, we can make it a little bit nicer by adding. You can add the counts. So so you have the measure of effect estimated within each study. You can see the label for the study. Study 1, study 2. You can see the cases and totals for the treatment group, in the control group. It's kind of nice. I mean, this is not that far from the final publication. Okay, right. This is just 1 line. I mean, it's pretty good. So this is the unofficial user written commands method. Let's do the same job using the official. Now that we have Stata 17, you download it. Let's see how it works. So in Stata, meta-analysis, like any complex.
Just 1 second, Nicola.
Yes.
Would you please explain how to interpret the output?
Yes. So let's look at the output. So let's go through the output from the top to the bottom. So as you can see here, so this is Meta. 10 studies. This is simply summing up the participants. Here, just a reminder of what is the measure of effect. And why do you choose the measure of effect? Here, risk ratio. Okay, so that's the measure we are interested in. Based on this table, you can compute risk differences, odds ratios, risk ratios. So you have to decide what is the measure of effect, and then what kind of mathematical model we are putting forward underlying all those kind of expressions. So we're assuming we're using a common effect model. So we are assuming there is a common effect. All these different studies are trying to estimate the same effect of treatment. And so the only source of variability is the sampling variability. Whenever you take a sample, and you do compute an odds ratio relative to this, you're going to get a different number. And so there are different studies of different sizes, it doesn't matter. So we can see Meta is showing us the study-specific risk ratio. So let's pick the first one, 0.792, and that's the confidence interval. How do you get this? Because this is important in meta-analysis. So conducting the meta-analysis is trivial in the sense that computationally is just a line, but of course, as Gianluigi is encouraging me to do, okay, but let's interpret, let's get familiar with this output, okay? And so whenever you see statistics, getting familiar with the output is translated, okay, first you need to be familiar with the statistical methods you're using, the assumptions. So it's not that everything you need is written over there. Sometimes it's more misleading than others, because if you're overwhelmed by text and numbers and you don't know what to do with that, you're simply confused. Okay, but this is happening whenever you use, you save the time of the programming, you trust the company or whatever your researcher wrote this command. So you have to spend some time, getting comfortable with the output. And that's a minimum. So let's get familiar with this. How do you get this 0.79, 0.335, 1.874? This is a measure effect for study one. Do you want to check and get familiar with this? How do you get this? So this is the first line of data. So I'm going to watch the data in one. I'm going to watch C1, N1, C0, N0. So this is the first study. Okay. You see, when you have the data like this, do you want to know how 0.79 is coming from? Look at the 2x2 table for study one and do the math. But very simple. So you can use data as a hand calculator, just to make yourself confident with the type of output. So you just want to verify the calculations. So for example, what is the risk ratio? Display 9 cases divided by 117 subject among the exposed, divided by the ratio cases to totals in the unexposed. This is 0.79. So this number here is this number here, the risk ratio estimated for study one. The confidence interval, how do you get a confidence interval? Well, you need to know the standard error, the uncertainty, the precision of the risk ratio for study number one. How do you get that? Oh, I think it is the square root of 1 over the cases. Something like that. C1 plus 1 over C0. It should be something like this. Minus also minus N1 minus N0. So that's the standard error of the log odds ratio. How do you compute a confidence interval? Well, you take the log of this stuff. You take the log of it, plus or minus 1.96, 1.96 multiplied by the standard error, which is this stuff. So this would tell me the lower bound for the log risk ratio. You take the exponential value of it, and you get 0.33, which should be this. You see, it's amazing. So you use Stata not only to get the job done, but also your way to get familiar with each and every of those numbers, because there is a formulas.
Can I just ask you?
Yes.
It's as a non-statisticians, why would I bother doing this? Do you see that? So it's why would I do and recheck whether the computer calculations was correct, and then do the second analysis on the already provided data set? Why did I do that?
That's a good point.
It's my ignorance because
You just anticipated me. I was going to say the same thing.
The calculation is mine. That's just very similar.
No, it's true. But in fact, I really enjoy, having a especially because
when I do statisticians, I would exactly what you do because that's what I'm here to do.
No, but I just think that it's interesting from an educational point of view because I mean we do understand what there is behind these numbers that we get from the statistical output, but it's not really required to double check if the software is doing things
Yeah.
correct.
But yeah, so for meta-analysis, when you do that, you don't need to double check that. But for us to know, in a course like this, what is behind this, that's absolutely.
so there is actually, of course, I have the pleasure to know how things are working. But for example, this point number 3, data check. Now, if you're familiar with kind of certain basic kind of definition.